So to start us off today, I'm going to have you solve that triangle. Find the missing parts. And yes, it looks like it, and it is. Angle C is obtuse. So now, of course, the first thing you have to do is you have to find, do we have an angle on its opposite side?
Yes.
The only angle we have is the 23, and its opposite side is the 26. So we do have that. So that means we can use the law of sines. So law of sines is the length of the side, 26, over the sine of its opposite angle. So 26 over the sine of 23 degrees. Now the only other piece of information we have is the 48 millimeters, which is the length of a side, so that's going to go on top. Beneath that's going to be the sine of its opposite angle. Its opposite angle here is angle C. So sine of angle C. And yeah, that's what we're looking for here is angle C. Now we're going to cross multiply and divide sine of 23 times 48 divided by 26. Sounds about right. But now, yeah, so 7213. But that's the sine of the angle, not the angle. So we have to do an inverse sine. Yep. Second sine, second answer. Yep, 46.17 degrees. You got her. So angle C. But that's an obtuse angle. Since that's an obtuse angle, that means 180 minus 46.17 degrees. 133.83 degrees. That's why I gave you the picture, and that's why I pointed out that that was an obtuse angle, because when you go to label that as 46 degrees, it should stick out to you something's wrong there. Now to find B over here, it's 180 minus the 133.83 minus the 23, which is going to give us 23.17 degrees. Now that we have all the angles, we have two of the sides, we can find the third side over here, side little b, still using our law of sines. Now, at this point, we have two pairs of angles with their opposite sides. But I want to go back to the original information, the ones that were given to me, as much as I possibly can. I mean, there are times when I can't do that, but right now I can, so I'm going to. So it's 26 over the sine, 23 degrees, equals, now I'm trying to find side B here, so that goes on top, side B, over the sine of 23.17 degrees. Now as you look at this, you should notice those two angles are really, really, really close to the same, which means the length of these opposite sides should be really, really close to the same. So the 26 times the sine of 23.17 divided by the sine of 23. Should be just barely larger than 26, and it is 26.11. And as always, we stop and take a look to make sure our answers make sense. And yeah, 26.11 is just barely larger than 26. 23.17 degrees is just barely larger than 23 degrees, so it does all fit in. Questions?
I didn't get the thing.
The 26.11?
I had 26.18.
Did I punch something in wrong? Yes, I did. I missed the 7. I see that. Let me try it again. 26 times sine 23.17. No, I just the 7 didn't register when I put her in. 26.18, you are correct. So there you go, 26.18 millimeters. What do you think? Bender sharp stick in the eye? Not sure yet, Cody.
I think
So on this one, I'm going to give you a few minutes to work on it. To solve the triangle. We go to set this one up. Come on. And we have our angle on its opposite side. So 1.1 over the sine of 38 degrees equals 2.4 over the sine of b. We cross multiply and divide here. Sine of 38 times 2.4 divided by, oops, that's not going to work. Sorry, sine of 38, got to remember to close my parentheses, times 2.4 divided by 1.1. And we get the sine of b is 1.343. What's wrong with that? Sine can never be greater than 1. If we did an inverse sine, then we're going to get an error. What that means is, in this triangle, if we have an angle here of 38 degrees, and this side here is 2.4 inches, it takes more than 1.1 inch to reach down. This side here never reaches down. No matter how far you extend this side out, this one will never reach down to that side. It's too short. This is not a triangle. So it can't be done. What's that? I'm saying if this is 38 degrees here, and this is 2.4, this side 1.1 inch is not long enough to reach back down here to this. I mean, the minimum it could be is if this came down and formed a right angle, and it's not long enough to even reach it at a right angle. So it's just too short. So it's not really a triangle. It doesn't work.
We're gonna do something like that.
Someday, maybe.
What would you,
Just say it doesn't work, or not a triangle, or just some sort of a comment that the side's not long enough, or doesn't make a triangle, or just doesn't work. Anything like that would be.
Sine can never be more than 1. And what is it? Cosine?
Sine and cosine can never be bigger. They're always between -1 and +1. They can never be larger than 1 in either direction.
Do you talk at all about the size of the triangle, the sum of the two sides?
Oh yeah, yeah. You still look confused, Jason. Okay. Let's do an example that actually works, huh?
now how long is there?
Oh, come on, I've got to have a little fun.
Making me waste paper. Yep, that.
That's not a waste of paper. That's a learning experience for you.
Not a learning
Those are bad trees anyway. There you go. Solve the triangle. Find the missing piece. The key to starting this one, of course, is we do not have an angle on its opposite side. We have two sides, but we have the angle that's in between them, which means law of sines does not work. We are resorting to the law of cosines.
So then it's the square root of 32 squared plus 29 squared
Perfect.
divided by
Nope. So minus
the minus
2 times 32 times the cosine of 68 degrees. So second square root 32 squared plus 29 squared minus 2 times 32 times 29 times the cosine of, what was it, 68? Now remember, on my calculator, I only have to close the parentheses once for the cosine. On many of yours, you have to close it once for the cosine and close it again for the end of the square root. So I get 34.20. So C is 34.20 millimeters in length. No, I'm going to pause it right there and let you. Law of cosine should never have to be used more than once on an individual problem. Once you've done that, now you do have a side in the opposite angle. So now it's back to the law of sines. So you have, unfortunately, you can't go back to original information anymore. You have to use that side you calculated. So it's 34.20 over the sine of 68 degrees. Is going to equal, now out of habit, I always use the smaller of the two sides just because it's safer. But 34, the side we just found, is our biggest side, which means the 68 is our biggest angle. So we really don't have to worry about any obtuse angles coming up here. But let's go with it. We're going to use the 29 first. So that's going to be over the sine of angle B up there. And we'll cross, multiply, and divide. So sine of 68 times 29 divided by 34.20. 0.7862. And then it's going to be an inverse sine. B will be the inverse sine of that. So second sine, second answer, 51.83 degrees. So that's B. And then, of course, that makes A 60.17 degrees, correct? So solve this one quick. Okay, so again, we have two sides and the angle between them. So our first step is going to be to find that opposite side using law of cosines. So A is going to equal the square root of, anybody? 40 squared plus 18 squared. Perfect. So let's punch that in and see what pops up. So the square root of 40 squared plus 18 squared minus 2 times 40 times 18 times the cosine of 23 degrees, closed up. 24.46 is A. So 24.46 millimeters. From here, what should we do next? Law of sines. And we're going to use that 24.46 over what? Sine of 23. Now, here's a case where we definitely should use one side first. Which one? We should use the 18 instead of the 40. That'll show, it'll be obvious here in a second why. So it'll be 18 over the sine of angle C. Good. Cross, multiply, and divide. Sine of 23 times 18 divided by 24.46. So sine of 23, close it up, times 18 divided by 24.46 gives us 0.2875 as our sine. So angle C is the inverse sine, so second sine, second answer. 16.71 degrees. So that's angle C up here. Angle B now is found just by subtracting from the 180 degree total for the triangle. So 180 minus 23 is 157. Minus 16.71 is 140.29 degrees. The reason I wanted to find angle C first, obviously because it was across from the smaller side, so I knew it was the smaller angle. So I knew it could not be obtuse. Remember, only the largest angle in a triangle can be obtuse. So that's why I chose to do that largest side last, because there's a possibility this opposite angle could be obtuse. And I don't want to put ourselves in a spot where we have to guess whether we have to use the angle we get or its supplement. One last example I want to do, and then yes, we are having a quiz today, since Cody begged for it.
Whatever, if you guys pay attention, just write down exactly what he's doing. It shows you what it's showing on. I don't know, like, all I do is write down like, what he puts up on the board and like everything else.
Yeah, well, I can't take no.
Here you go, guys.
Not making fun of it.
You're getting the quiz whether Cody wanted it or not, so don't worry.
Just throw me to the wolves.
Now, in this case, where we have all the sides and we're looking for an angle, remember, things change a little bit. First of all, we have to pick which angle we're going to look for. Does anybody have a preference, A, B, or C? C? Okay. Cody wants C, so we'll go for C. From the formula we worked on yesterday, since C squared equals A squared plus B squared minus 2AB cosine of angle C, we could solve this for the cosine of angle C. And what we came up with was the cosine of angle C is equal to C squared minus A squared minus B squared over negative 2 times A times B. That's the cosine, so then we'd have to do the inverse cosine of that. We can enter this all at once, but it is kind of tough to do.
How do you suggest writing it in that calculator?
To put it in your calculator, here's how I would do it. C is equal to, now it's what on the other side of the equal sign is what you're going to put in your calculator. You're going to do the second cosine, which gives you that cosine negative 1. And that should automatically bring up a parentheses. Just like that. But you're going to need another parentheses. Put in a second one, open parentheses. So now you have C squared, which is the 38. So 38 squared. Minus A squared, which is the 41. So minus 41 squared. Minus B squared, so minus 46 squared. And then you're going to close that parentheses. Now you're going to hit divide, and you're going to open a new parenthesis. Now remember, you've got to use the negative key here, which is this key down here, not the subtraction key. It'll be negative 2 times A is 41 times B, which is 46. Then you got to close the parentheses twice. And hit equals, and it gives you 51.41. I'll leave it right there for you. So then, of course, once you have the 51.41, then it's just a matter of law signs again from there. 38 millimeters over the sine of 51.41 equals, and I would use the smaller one even though we don't really have to here. Actually, in this case, you probably should. I'll stick with the 41 over the sine of A. What'd you guys get for angle A? 57.49 works for me. Then, of course, subtract from 180 to get B, which is going to be 71 something.
71.11.
Perfect. Well, good news. There will be no homework for tomorrow. Bad news is I'm about to hand you a quiz.